This question addresses the idea that how do we calculate work done, or how do we determine the work done from the force distance graph or the force displacement graph. So right in this graph you see a variable force is applied on an object and it is traveling the distance, so distance is increasing. So what is the work done from the P to Q? So I will show you the two or three different scenarios in which the force is changing. So the first scenario is, don't you think this one? So if a box is attached with a spring and you compress the spring and then you release it. So while this object, this box will be moving towards its equilibrium position, the force will be changing. The spring force will be changing. It will be decreasing. But if you compress the spring, then that spring force will be increasing its magnitude. So if I draw the graph, taking force, the magnitude of the force on a y-axis and the magnitude of the distance on x-axis, right? So the graph will be like this proportion line, and all the area that is under the graph under this line is representing the work done. So it means that in a force displacement graph or the force position graph, this area represents the work done on that object. Okay, and then this work done is equal to the change of energy, because work done is the transfer of energy. I want to quickly show you the two other scenarios also, in which the force is increasing or changing, and how do we find work done. So for example, on this car, if a force is increasing, right, so you see that it is traveling more and more distance in every next interval. So let's say this is a position P and this is a position Q. During the position P and Q, the force is still increasing, but what is the work done during that? It is just like I have shown you here, that we find out the area under the graph to find out the work done. We will do the same. We will find out the area under the graph, this whole area, which is the sum of these two sections of the graph, y and z, that represents the work done. And in the same manner, this is another scenario. If the force of tension in a cable is increasing and it is accelerating up, so if it is position P and this is a position Q, so during this, what is the work done? That is once again the area under the force displacement graph. So it is sum of sections y plus z that represents the total work done from P to Q. So the right answer should be the option C.